I want to introduce the next presenter, Elkanah, who will be taking us through Pandas. So Elkanah, you're free to share your screen now and start your presentation. Thanks.
Yes. Hi, everyone. My name is Elkanah, and I'm going to take you through Pandas. So in this tutorial today, I'm going to cover introduction to Pandas, Panda data structures, indexing and selecting data, reading data into Pandas, and some basic operations on the data. Okay, let's get started. So Pandas, these are a high dimensional data manipulation tool. Usually it's built on the NumPy package. This implies that much of what we have done in NumPy is replicated in Pandas. So the basic key structure of Pandas is a data frame. And take a data frame as a table that has rows and columns. So data in Panda is often used to do statistical analysis using the SciPy package. You can also use the result to plot using matplotlib and some machine learning algorithms from the SciPy package. So Pandas is a powerful tool when it comes to data manipulation and analysis. So we start from the Panda structures. We have three main data structures in Pandas. And the first one is a series. Series, this is a one-dimensional array-like structure with homogeneous data. Take it as like a column of data. Data frames, these are two-dimensional data structure. It has rows and columns. And a panel, it's a three-dimensional data structure. It's like data frame, but you are collecting the data on on a time interval. That's why you call it a three-dimensional data structure. So we start by creating a series. And to start, we import the Pandas library as a PD, and we were told we were told it's not like you can use n term here or n word of your choice, but for this we are going to use PD. We import Pandas as PD. Then we start by creating an empty series, and we name or we assign it to this term here, empty series. And we use the series constructor in Pandas. That's the pd.series. If you print this, you see that we have printed an empty series. It has nothing in it. So there are different ways we can create a series in Pandas. We can create a series using a list, using a dictionary, using an array. So we start by creating a list using creating a series using a list. Take an example of this list here, a list of integers, 2, 3, 5, 7, and 8. So to create a series, let's call it a series list. We use the series constructor or series function, that's pd.series. Then in the bracket, you put the name of the list. If you print it, you see we have printed a series that has the integers. As well, you can decide to put this series inside this instead of having to name it. We are just naming for purposes of convenience. We can also create a series using an array. take a look at this. We have our data and p.array. Okay, for this, we have to use the NumPy package to generate this array. np.array, we have this array, women promoting science to the young generation. So we convert this array to a series using this constructor pd.series. And this is our output. You see, it's a one-dimensional array. It's just a column of data. We can also use a dictionary. And for this, I suggest that you do it in your free time or maybe after the tutorial. Let's go and see how we can create a data frame in Pandas. And as I said earlier, these are the basic key structure in Pandas. So we can create data frames in different ways. We can use lists, arrays, and the dictionaries. So we use the data frame constructor. That's pd.dataframe. I'm sorry for the name here. It should be capital D and capital F. So it's case sensitive. If you use the small case, it will return an error. So to create an empty data frame, let's call it a df. We use the data frame constructor pd.dataframe. And if you print it, you see we have an empty data frame. It has nothing in it. It's empty. So let's create a data frame using a list. We use the same list here. We have integers 10, 15, 45, 2, and 1. Then you use a data frame constructor, and we name the data frame df. So pd.dataframe, then the name of the list here, or you just write the list directly here. So it returns a data frame. Of course, it's a column, but you note at the top we have a label. But when we were creating a series, we didn't have a label. Take note of that. So we can decide to label this data frame by specifying or inside the constructor pd.dataframe. After specifying the name of the list, then columns equals to, use this square brackets. Then you write the name of the column you want, or the name you want to assign to the column. You see we have a column that has a label marks. We can also create a data frame using dictionaries. Let's take an example of this dictionary here, data, that has a name and age as a key. Name contains a name of people and the age So we use the data frame constructor as we had done earlier. And if you print the output, you have a two-dimensional array or data that has name and age as its columns. We can also try to check how we can create data frames using other methods, like using array, the one-dimensional, two-dimensional, and many other ways. So let's look at how we can deal with rows and columns in a data frame. So by this, I mean that let's see how we can select rows, we can delete, add on, and rename values in a data frame. And for this purpose, we create a data frame using a dictionary, which we'll be using to illustrate the above operations. So we have this data here, or dictionary, that has name, age, country, and qualification of some people. We use NumPy to generate this NP. none to generate a null value. So we convert this data into a data frame using the constructor, and we have this as our output. So this is our data. I want to use this data to understand some of the basic operations or manipulations. So let's start with selecting. We can select a column in Pandas by either calling their name or the index, okay, the location it is using the index. So we start by using the specifying the name of the column. And to do that, you use a square brackets after the name of the data frame. That's df, because we are named our data frame as df. So df, the square brackets, and you specify the name of the column you want to display. So you have a column as this. If you want to display the column name, you can use the double square brackets as below. So it has returned column name in it. We can also select more than one column. By specifying df, the double square, because I want it to display the names of the columns. Then we want to display name, country, and qualification, 3 columns. This is what we have from this. You see the column that had age is not there. So let's look at how we can select rows. We can select rows using the .log function in Pandas. And to do this, you just specify you start with the name of the data frame, then .log, then you specify by either using an index or the name of the row you want to select. So let's start by using the index of the row. So if we use df.log and specify the index of the row we want to select, let's say index 1. So index 1, this is the second row because indexing starts from 0, 1, all the way. So index 1 is the second row. From our data, let's see. The second index 1, is Susan. Let's see what we have it. Yeah, we have Susan. And let's run all the columns of index 1. We can also specify we want to select a specific row by specifying the name of that row, or maybe the name that is in that row. We can use the same procedure. After specifying the name, df.log the name, then you put your condition there. I want the results of this person, Mary, to appear. So it will go through the dataset, and any name that it finds that's Mary, it will return it, the values, all the rows regarding that name. You can use another logic, that's the iLock. This one will select, if you want to select a specific rows and columns, you can use their indexes to specify them. Let's look at this. We specify the name of the dataset or the data frame, that's df.ilock. Then we can specify, the first one is specifying the rows. We want from the rows from index 0 to index 2. And from what we learned in NumPy, it doesn't pick the last one too. It's 0, it picks the one just before the last index here. That's 0 and 1 in this case. Then for the columns, we want also to select 0 to 2. That's a column 1 and column 2. So this is what we have. So basically, this is how you can select data in a data frame. Then we can also check how to rename columns. You can decide to rename all columns in the dataset by using df.columns, this function df.columns, that's the name of the data, .columns. Then you specify the names you want it to replace the previous ones. So in our initial data, we had name, age, country, and qualification. You see, we have changed it to names, old, origin, and qual. Let's also look at how to check for missing values in our data. To check for missing values, we use the function is null. You specify the name of the data, then dot the function to check the missing values. So this is the name of the data, df dot is null. You see, it has returned a data frame that contains if this entry here is null, it will return true, and if it's not null or it has an entry in it, it will return false. So if you look at this table, we have only one true. Then we have only one missing value. But what if you have a large data set, like has more than 1,000 rows and many columns? How will you get that? So we add the sum to this null function so that they can sum for each column. So df is null, we add the sum. So this will return the total number of missing values in the data frame. We see name, the column name has 0 missing values, age has 1 missing value, country has 0 missing values, and qualification has 0 missing values. So after knowing how we can get the missing values, sometimes it's good to know how to treat these missing values. You can either decide to drop the missing values or you replace them. Let's start by replacing the missing values. We replace missing values in a data frame or in a data set by using the function fill NA. I don't want to alter the initial data frame, so I call this one, the data frame I'm going to replace as completed F. This will be df, the name of the data frame, dot fill NA. Then I want to fill all the missing values with 0. You can decide to fill it with anything. You can decide to fill it with the mean, there are many ways on how to deal with missing values, but in this case, I want to fill the missing value with 0. So if I call the data, I find that our missing value here, which was from this none, it has been replaced by 0. So if you had a large data set, you can't see it. So you can check the sum of all null values in it. If you check the sum of all the null values or the missing values, we see that there is no missing values in this data set. Basically, that's how we can replace missing values. We can also decide to drop the rows and columns with the missing values by using the function drop NA. So you can choose which way you want to drop the null values. You can either decide to drop the null values row-wise or the column-wise. So if you have to do that, then you need to specify inside the function drop NA the axis. If you select 0, then you are going to drop row-wise, and if you select 1, then you are going to drop your null values column-wise. Let's see that, how it works. Sorry. So let's drop the null values row-wise. by selecting the axis as 0. You see the row that had a null value has been dropped. Let's try to drop the column that has a null value. We use the axis 1, and it has dropped the column with the null value. That's the edge. Then let's move ahead and see how we can read data into Pandas. We have different file formats. We have a CSV, we have XLS, we have .tab, we have many file extensions. But in this case, I'm going to look at the CSV file format. To read data into Pandas, you must call the library Pandas. Then you use the function, the pandas.read, then you specify the file format. Let's look at this. Import pandas as PD. This you call the library pandas. Then you read the data using this function pd.read, then the name of the extension, the file extension, CSV, XLS, or Excel. Then inside the brackets, you specify the path of your data. If you are working the same directory, you can decide to call the name of the data directly, sales, like this one is sales.csv. But our data is on GitHub, so I decided to include a link to the GitHub. So, and we have assigned this data, we have named it as a dataset. So you can call dataset. But assume you have like 100,000 rows and many columns, then your computer might be slow, or it might consume a lot of space or memory. So you can decide to view the first few rows of your data by using the function head. So you specify the name of your data, that's dataset.head. It will return the first 5 lines of the data. As well, you can decide to see the last rows of your data by using dataset.tail. You can try it in your own time. Sometimes you might want to see, like I want to see 9 rows or maybe 3 rows. Inside the head function or tail function, you can specify the number of rows you want. That's dataset.head. Maybe I want 2 rows. It returns 2 rows. Then suppose you have a large data set, you can decide to check the shape, size, and dimension of the data. As we did in NumPy, we can do it also in Pandas. So to check the total number of rows, all the shape of the data, the rows and columns, we use the shape function. That's dataset.shape. So we have 998 rows and 12 columns. We can also try to check the total number of entries or elements in this dataset. Basically, the total number of elements is the rows multiplied by the columns, the number of cells in the data. So we have 11,976. That's, if you check it, it's 998 times 12. Then you can check the dimension of the data, sorry. You can check the dimension of the data using the function ndim. So you see our data set is a 2-dimensional, rows and columns. The next, we can decide to check the unique values in the categorical variables. So for all categorical variables, you can check the unique values in it by using the function select data types. then you specify, because we're going to check for categorical variables, we use object data type. So for our case, we use our name of the dataset, that's dataset.select data type. We specify, because we want categorical variables and they are stored as objects, dot apply. We use this function here, pd series dot unique, n unique, then axis 0. Then if you call it, you realize that it has returned the number of unique values. In the column transaction date, we have 987 unique values. Product, we have 4 unique values. Price, we have 9 unique values. Then as we had done earlier, you can index and or subset using the log function. Let's try to use it in this data. And before we do that, let's we can set an index to help locate this data. We can decide to allocate an index that's more unique. And in our case, we can use the transaction date. If you observe that we have a transaction date, the date and the specific time. Then we can decide to use to select rows or index rows from 0 to 3 by using the log function. So 0 to 3, it implies we need the first row, second row, and the first row, second row, and from index 0 to index 3. This is what we have here. We can also decide to use the ilog function, as we had done earlier. The name of the dataset .ilog, then you specify the rows and the columns by their indexes or indices. So these are the results we have. Then we have another method of selecting using the ix and ilog function, but I'm not going to cover it today. I suggest that during your free time, maybe after the tutorial, you can go and find out more information about it. Then let's try to use what we have done earlier to check for missing values in our dataset using the is.na function, then the sum to get the total missing values. We see we have one missing value in the column state. Then we can decide to fill the missing values, just a replicate of what we had done earlier by using fill NA. But in this case, I've decided to use a different method to fill this missing value. I've used the method ffill, that's the forward fill. In this forward fill, it will fill the missing value by, it will fill the missing value by the value that is in front of it. And we have the backward fill and many other methods. So if we have called this, we have assigned this data that we have filled with the missing value by new data. So if we call the name of the new data, or we try to check the number of missing values in it, we see we have no missing values. We can also try to get like an overview of the data by using the describe function. So you can use new data.describe function. I've included all. You can specify the column you want to describe or to get the information about it. So you see the describe function gives you the count, unique values in it, top value, frequency. And in some cases, if you specify the rows, you can get the minimum value, the mean, and the rest, if it's a numerical value. So you can summarize a specific value, specific column variable by subsetting. As we saw, we can select the column. Like new data, we select the column payment type. Then to get the total number of values in it, we count the values because this is a categorical variable using the function value counts this way. Then we have this payment type as we had Visa 522, MasterCard 277, and the rest. You can also try to do a cross tabulation, checking the two categorical variables using the crosstab function, pd.crosstab. Then you specify the one you want to appear in the rows and the columns. So this is what we have: the payment type and the product as we had specified in the function. They return this. This is basically how you can get some functions like those. Then you can also decide to check the number of data types you have in your data set by counting all the data types using this function, data types dot value counts. This value counts the number counts the number of categories in it. So like object, we have 10, float 64. Float 64, we have 2. Then we can also try to convert the list of columns, or we can try to get the number of columns in our dataset by using the dataset.columns command. If you use this command, it will return all the columns in your dataset as a row. But if you want to name them as a column, you use another function to list. So you are converting these columns into a list. You see it has arranged it into a list. So I'm going to invite my colleague to take you through the exercises. I hope you followed and you understood. Thank you. Deborah, back to you.
Okay, thank you very much, Elkana. So we move on to the exercises quickly, and that will be handled by Salome Ose. So you could go ahead and share your screen, Salome.
All right, thank you so much, Elkana, and thank you so much, Deborah. I would like to share my screen now. Okay. So, hello everyone, and welcome to the practice session of
Salome, could you please zoom in?
Zoom in, okay. Sure, let me reduce the chat so that I'll be able to see what people post, and then also zoom in. Oh. Is that okay?
Yeah, it's fine.
Or I think it's too big. Oh, my machine is frozen. Okay, this should be okay. Yes? Okay, so our first exercise is to create a data frame with the following exam details. So let's go ahead and do this. We're supposed to create a data frame that contains the details that is below. So the name of the data frame that we are going to, the name that we are going to give the data frame is exam data. So it will contain this dictionary, the name, which is Mary, Tim, Kate, James, Emily, and so on. And then it's also going to contain the scores. So we can also see that, as Elkanah said, there are some non-values inside the score as well. And then we also have the column called attempts and qualify. So let's get right into these exercises. Any suggestions? Okay, maybe I give people time to do this. Are people confused? Remember, Elkanah talked about having a data set and trying to convert it to a data frame using the function data frame. So in case you forgot, that's a hint. Okay, if there are no answers, let's try to look at it together. So the first thing Elkanah said was to import Pandas, the library. So he also said that you could import it, naming it as what you want. So let's do what Elkanah did. So we import Pandas as PD, or we could also just import Pandas and use the full word. So now to convert this into the data frame, this is a bit too long. So let me just try to copy. Yeah. So also another way is that there's the solution here, since it's too much to type and it might take a lot of time. So let's just look at what answers we have here. So later you can go into the notebook. It's online on the GitHub and you can follow. If you didn't get anything right, you can also ask me questions as I am trying to explain these exercises. So like I said, we'll import the pandas and import the NumPy as well. Now this is the exam data that we have. So it contains this, and that's what is done. So now to convert this into a data frame, we call the data set data exam. So this is another naming that we've given to it. And then we call the pd.dataframe function. And this gives us the exam date. And then we tell it that the index of this data frame that we have to name is the labels. So let me copy this, paste it, and show us how this is going to work. So let's copy it from here, paste, and then remove some of these things so that it does not give us any errors. So, okay, this is already imported. Solution. Let me also clean this. And so, yeah, I think we are good to go. So yes, this is the data frame that we have created. It has the name, the score, the attempts, and then qualified. Now, I think now that I have given us the solution to the first exercise, I hope that the second exercise is okay for people to do. So the second exercise is saying that we should find the summary scores of the students. We should find the summary scores of the students. Oh, I think I have something from Edmond. Edmond said, okay, import numpy as NP, okay, and then convert it to, yes, Edmond, you're right. You're right. And that's a very nice answer. So let's get to finding the summary scores of the students. If I have a data set and I want to find the summary scores, so what do I do? Any answers? And if you have any questions too, you can ask me and I'm going to answer you. If it would take you too long to type all of the data, you should just tell me the command used for it. That will do. Just the command used for it will do. Okay, so let's try to solve this together once more. So remember we named our data as data X. And then for telling how much scores that we have, oh, Emmanuel. Okay, I'm seeing answers. We make use of sum. Okay. I think that you would want to do summing if you want to use the sum. And then Gloria, you're right. So we use the describe. Also BB, summary is also right. So I think Emmanuel, you can look at the sum again. You can print it out on your computer and you see what it gives you so that you know exactly what I'm talking about. So let's go with Gloria, and then good answers as well, all of you. So Gloria said we should use this. Now we put the score. So dot describe. Cool, so we have our answer there. Now let's go to, if anybody has any questions, you can contact us later for explanations. So we find the summaries. Now the third question is how many missing values are in the data frame and which variables have the missing values? So you could put suggestions there. Any suggestions? And also, I would like to say that because of time, Pandas is not a very complicated thing to do because it has a lot of built-in functions that you can use yourself. So you could go to you could go online and type Pandas and everything would pop up for you. Anything that you want to do in Pandas, I mean, yesterday I saw that on the chat someone said Google is your friend. So you could go to Google and then you can get all of the answers. And if you think that you're stuck with anything, you can also contact us and then we'll be here to help you. So because of the time, I wouldn't be able to do the exercises 4 and 5. But hopefully these are very, very good exercises for you. And then in your notebook, you could see that we've provided solutions. So when you click on the double click for solutions, it will give you a very vivid solution. But I suggest you try it out yourself before you check the solutions. So Emmanuel has given an answer. He said we take the data set and we say we use the isna function and then sum it. Yeah, good answer. BB also says data is null and then sum. So let's try out what they have said. So our data is data X. Sorry, data X. And then Emmanuel said we should put dots is NA and then sum. Okay, that's the magic. Thank you so much, Emmanuel. Now let's try for BB. So I'm just gonna copy what is here and try for BB. So BB said is null. BB, we have an error. Any solutions to this error? Good. BB gave an answer to her error. Great. So thank you, BB. Thank you, Emmanuel. Thank you, everybody, for following this tutorial. And I am glad that you enjoyed the Pandas session. So if you have any questions, you could ask us later. So Deborah, over to you.
Hi. Okay, thank you so much, Salome. So would want to